and final reaction type that we're going to be covering is a redox reaction. Redox reactions are made of two parts: reduction, which is going to refer to a reduction in charge, and oxidation, which is an increase in charge. And so when we talk about reduction oxidization reactions, or redox reactions, we're really looking at the trading of electrons. Remember, an electron has a -1 charge, a -1 charge. And so if I gain an electron, I'm going to lose some charge and thus be reduced. So if I've got aluminum and it gains 1 electron to become aluminum minus, well, then that would be a reduction. This aluminum was reduced. Alternatively, if I had aluminum and it gave up, as aluminum commonly does, 3 electrons to become aluminum 3 plus, that would be oxidization. It increased in charge. Plus 3 is more than 0. Okay? So there are some rules that we're going to need to use when looking at redox reactions, because not all redox reactions are going to be as simple as aluminum turning into an ion. Sometimes we're going to have something like the combustion of methane. This is going to be a redox reaction because we are going to be trading some electrons. Now, how are we able to figure out how these electrons are moving? Well, we need to assign something called an oxidization number, or an oxidation. I have a bad habit of saying oxidization. It's oxidation number. And we're going to need to be able to assign these two elements. And it's actually just a set of rules that are pretty straightforward once you get the hang of them. So let's look at those rules. There's going to be 6 of them, okay? So let's go ahead and put a numbered list here. 1. Rule number 1. The oxidization of any monatomic element is 0. And this will include the diatomic gases. Because these will be gases that are bonded only to themselves, right? So they are technically monatomic. It will also include things like sulfur, S8, which this is how sulfur normally bonds to itself when you have a pure lump of sulfur. And that applies to all metals. So sodium, when we have pure sodium, or when we have pure aluminum or some copper, all of those would have an oxidation number of 0. Okay, that's our second rule. The second rule is that ions' oxidation numbers equal their charge. And that's going to be whether these are ions in a molecule or not. So an ion's oxidation number equals its charge. So Na plus, oxidation number would be +1. Mg2 plus would be +2. F minus would be -1. Rule 3, total oxidation number will equal 0 in a neutral compound. So something like CH4, the total oxidation number would be 0. Something like NO2, total would be 0. AlF3, our total will be 0. But what about something like something like the nitrate anion, NO3 minus. Well, that would be an ion. And so its total charge is going to be -1. So the total charge, the total oxidation number will be -1. Same with something like NH4 plus. The total ionic charge is +1. So the oxidation number will be +1 for the whole compound. Okay? Next. Our fourth rule is for hydrogen. Hydrogen is going to be +1 except in a hydride. And hydrides are going to be things like if I've got CuH2, where hydrogen is acting as the anion. We have not seen this, and in this course, we won't see this. So for all intents and purposes, you can pretend that there's no exception to this rule, and hydrogen is always going to be +1. Rule number 5, oxygen is going to have a -2 charge, except in peroxides. A peroxide is going to be something where we have O2 with a total of a -2 charge. In that case, its oxidization number is going to be -1. Each oxygen would have a -1 oxidation number. And that would really align with that ion's oxidization number. Okay? And the final rule is going to be fluorine is always -1. Always. Fluorine has no exceptions. Following fluorine, chlorine, bromine, and iodine will all have a -1 charge unless rule 4, 5, or 6 with fluorine, it gives them an exception. So if bromine is attached to oxygen, bromine is going to be positive because oxygen is going to be -2. If chlorine is combined with fluorine, chlorine is going to be +2 because fluorine takes the exception. Okay? So these are all of the rules of our oxidation numbers. So let's try and put these into practice and see if we can figure this out for the reaction that we stated above. So we've got CH4 plus O2 becomes CO2 and H2O. Let's see if we can figure out which item here was reduced and which one was oxidized. So first off, CH4. Do we have a rule for carbon? No, we don't, but we do have a rule for hydrogen. Hydrogen is going to be +1. So hydrogen here, that is, each hydrogen is +1. There's a total of 4 hydrogens. So on this side, I've got total of +4. And so carbon has to balance out a +4. This is just like when we were doing ions. So carbon now is going to be -4. It's got to be -4 in this compound. O2, what is this going to be? Well, oxygen's always -2, right? Oh, but rule number 1, monatomic element is going to be 0. And oxygen, O2, all by itself, that is monatomic. So its charge is 0. Then we go to the other side. We've got rules for oxygen here. Oxygen's down a compound where it's going to be -2. And there's 2 of them there. So now this is going to be -4. So our carbon has to balance out a -4. So carbon is +4. There we go. Okay. And then we've got oxygen over here. That's going to be a -2. These hydrogens are going to be a +1. And that makes sense. +1 times 2, that's a total of +2. So there we go. There's our redox reaction. And so we can see that carbon started from a -4 and went to a +4. And according to our rules, that would be oxidized. That makes sense. It increased in charge from -4 to +4. Now, the oxygen went from a 0 to a -2. Its charge was reduced, so it was reduced. Oxygen was reduced, carbon was oxidized. So hopefully that makes sense. When we have a redox reaction, we're always going to have one of our compounds being reduced and the other compound being oxidized. But it is possible that we'll have something like this hydrogen here, where its oxidation state did not change at all. And so this would just participate in the reaction and just carry its own electrons and just trade partners. But the carbon and the oxygen, those are going to have some electrons transferring back and forth.